This is a video covering factorisation and indices for Year 9 students, covering 5.2 and 5.3. Okay, so off we go. So we've got some expressions here and we need to factorise. Now the basis of factorisation is that we pull out the highest common factor of term 1 and term 2, and then we divide each term by the highest common factor. HCF, HCF. Now, you rarely write this down if you've become fluent in the method. So let's do the first one as an example. The highest common factor of 9, and 9 is 9, and we can take a y out, and if we divide we get 1 plus y, and we can multiply the bracket out to use the distributive property to verify our answer. So the highest common factor of 12 and 15 is 3, and the highest common factor of m cubed, and m is the lowest power, it's always the lowest power, which is m. So we need to decide what we're going to put in our parentheses to get the original term, or another way of thinking is what is the division of each of these terms by 3m. So we get 4m squared plus 5. The highest common factor of 20 and 30 is 10. We take the lowest term out, that is a, b squared, and we need to put a 2 in here, and a b, and we got a subtraction here, and we need to insert 3a squared. Okay, so first of all we take the negative out. 4 is the highest common factor of 8 and 4. We take the lowest value of p out, which is p squared. We take the lowest value of q out, which is q, and inside the brackets you have 3p cubed plus q squared. Okay, so here we have some quadratic trinomials. They are monic, meaning that the coefficient of the leading term in A is 1. They're trinomial because we have 3 terms, and they're quadratic because the highest power is 2. Okay, so let's use a different color. So we need to think of product factor sum. So we need to look at the factors of 16. Well, 1 and 16 doesn't take us very much. 2 and 8, and we've got 4 and 4. So our product is 16, our sum is 10, and the factors we choose are 8 plus 2 because they equal 10, and they multiply together to give 16. Let's do our parentheses. So we've got 2 and 8 and x. Now again, we don't usually write down product factor sum. If you're not fluent in factorising quadratic trinomials, I'd encourage you to do it, But once you have enough practice, you can do these in your head. So the factors of 14, we need to make 9. It's going to be 2 and 7. Nice big parentheses. So we're going to have m, 2, 7. Now we need to make negative 9, so they're going to both be negatives. Okay, so we need to get this empty, and we need to make three. Okay, so let's consider factors of empty. Well, we've got 10 and 7, and 10 subtract 7 is 3. Y, 10, 7. Now we need to make positive 3, so we're going to have a positive there and a negative there. Okay, so factors of 12, which sum to give 4. The subtraction is just the case of adding a negative number. So that was going to be 2 and 6. 2 and 6. Got C, positive, negative. So we've got 42. That's going to be 6 and 7. N, 6, 7. We need to make a negative. Okay, so 27. How about 3 times 9? Because 9 subtract 3 is 6. So we've got an x, and we've got an x, 3, 9. Okay, so we've got 100. And we need to make 15. So let's go with 5 and 20. Okay, so let's move on. Okay, so these are simplifying indices. So we need to use the rule that if we have a m to the x multiplied by b m to the y, that's going to be a b m to the x plus y. So using that principle, 3 7s are 28, and we add the powers. So we've got a to the 4 plus 2, which is 27, a to the 6. Here we simply subtract the powers. We are using this law or rule. We've got m to the x divided by m to the y is simply mx subtract y, which gives us w to the 4. Okay, we can split this up. That is 5 multiplied by to the power of 0. You should know that anything to the power of 0 is 1, so that is simply 5. Here we use the distributive property. This is the same as doing, well, let's look at the rule first. If we have a m to the x all to the y, that is simply a to the y, m to the y, x. So using that principle, we have got 6 squared multiplied by y to the 5 squared, which is 36 y to the 10. Okay, so we need to combine these principles now, and I sometimes like writing these like this, 9 over 3, because we know that simplifies, multiplied by, let's do the a's, a squared over a cubed, and let's do the b's. We got 5b to the 6 over b squared. So that let's change colour. So if we simplify the numbers, we have 3. Simplify the a's, we have a squared. And if we simplify the b's, we have got 5b to the 4. So if we multiply that out, that is 15b to the 4 all over a squared. Okay. No squared there. Very bad, Mr. Winston. Okay, because 3 times 2 is just 1. Okay, so moving on. Okay, let's do this nasty one. Let's use a nice big bold red for this. Okay, so this is going to be 25 all over 4x to the 6 multiplied by 4 all over x cubed. The 4's cancel, and we're simply left with 25x to the 9. Okay. Express using positive integer powers. Well, there's a rule in indices, in index laws. This is 1 over m to the x. Yikes. That's not the rule, it's just a mess. Okay, so 1 over m to the x is the same as m to the negative x. Now we must be very careful, because we have some complications like a over b m to the x. Well, we're only taking the power up, so that just becomes this. And another complication could be something like a over b m to the x all to the negative, let's do negative f. So if we have anything to the negative, we can just invert the numerator and denominator, so we get b mx all over a, and I'm going to insert the power using a different color. that is to the power f. We multiply here to get power f and power f. Okay, so let's apply this principle. As a positive index, that's going to be simply 1 over 7. That is going to be 1 over a cubed. This is going to be, using this principle here, that is going to be 3 over m squared. So I'm going to rewrite this as 5a over 1 all to negative 2. Using this principle down the bottom here, we're going to invert our fraction, that is swapping numerator and denominator. Squared, well, 1 squared, well, let's do it. 1 squared all over 5a squared is just simply 1 over 25a squared. So using that principle again, that is just 7 over w. Using that principle again, this is 3y over x squared. So we square the 3 and we square the y, and then we square the x to give 9y squared over x squared. It's a little bit cumbersome squaring individually. If you've had enough practice with these, I think it's sufficient just to write this straight away. 3y over x all squared, 9y squared over x squared. Okay, so let's have a little pause. Get my breath back. Okay, so scientific notation. So let's write the general case. Let's get rid of this. So when we write in scientific notation, I'm going to do this down the bottom. We're going to have a number a multiplied by 10 to the n, and we're going to say that a is greater than or equal to 1 but less than 10, and we're going to say that n is an integer. So writing that is a little bit juvenile. I just like to put this n as a member of the integers. Also, this is a magnitude. It's a bit mucky. Okay, so here we get 5.062, and I like to jump here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Times 10, that seems wrong. Let's get a finer pen. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that was right. Okay, we've got 7.3 times 10 to the negative 1, negative 2, negative 3, negative 4. And this one's an interesting one. So that is just simply 5 times 3 multiplied by 10 to the 4 multiplied by 10 to the 7. So this gives us 15 times 10. If we add 7 plus 4, we get 11. Now, alarm bells should be going off because 15 is greater than 10. So we're going to make this 10 times smaller, 1.5. So we need to make this 10 times larger to become 12. Oh, my favorites. Okay, so when we see something like this is called a difference of two squares, and they follow the format a squared minus b squared, a plus b, a minus b. So 121 is 11 squared, so we got x minus 11, x plus 11. So this is called a difference of two squares, and we have something else called perfect squares. Now they often get mixed up. Perfect square is like x plus 1 squared, y minus 1 squared, and even a minus b. All perfect squares. So look at factors of 16. Four and 4, x plus 4, x plus 4. Lo and behold, we can write x plus 4 squared, perfect square. Now hopefully we can recognize the pattern here. If we can't, we can approach this in a slightly different way. I'm going to do it up here. So we've got a squared minus 2ab plus b squared. Now we can split this up to give a squared minus ab minus ab plus b squared. Factorize the a's out. We can take a negative b out there. And we're left with a negative b, which is a negative b squared. And we should recognize that a plus b squared is square the first, square the last, and double the product. And similar with a minus b squared, square the first, square the last, and double the product. And that's what we have here. Okay. Okay, so we're making progress here. Sometimes it helps to really see if they are squares. I mean, if you've had enough practice doing these, you should be able to recognize this factorization. But if you want to show that it is a difference of two squares, you should know that 64 is 8 squared and 49 is 7 squared. If you need further convincing, we can and the factorization is this. Okay, so based on the same principle, we can factorize by grouping in pairs, but you should be able to recognize that this factorization is this. Okay, so what other exciting maths do we have? Okay. So we've already, there's 3 E's. So we've already done the first E. Okay, so we do have a common factor here. It is x to the 5, and we take that out to get x. Bad. To get 1 minus 9 x squared and that gives x to the 5, 1 minus 3x, 1 plus 3x. Okay, so hopefully you can recognize that this is m plus 7n squared. Square the first, m squared, square the last, 49n squared, double the product is 14mn. If you can't, you're going to have to factorize by grouping. The same with this. You should be able to recognize that this is 5a plus 3b squared from this identity here. Square the first, square the last, and double the product. You can see the 5 nestled in there, the 3, double the product, and you get 30ab. Okay, h. So we have a common factor of 2 throughout. So if we have a quadratic, we can factorize alpha out, and we can do the same here. Factors of 12, which give 1, well, it's obviously going to be 3 and 4. Now, you may be wondering how you decide which value is positive and negative. Well, I always think of it as we need to add or subtract to give negative 2. Well, the only combination there which gives negative 2 is adding to give negative 1 rather, is adding negative 3, adding negative 4 plus positive 3. Okay, let's move on. Oh, these are delicious questions. Okay, so I think it's best to split this up. So we've got 27m to the negative 3 all over 1 multiplied by 9m to the negative 2. Okay, so all this means is 27 over m cubed multiplied by m squared over 9. So we can complete some. This just gives 3 over m. Okay, so let's work out the parentheses first. So we're using power of a power rule. So this is just x to the a over b is x to the ab. So this becomes 4 over y multiplied by x to the negative 6 over x cubed. So this becomes x to the 4 all over y multiplied by 1 over x to the 9. And the simplification of that is 1 over y x to the 5. Do I agree with that? X to the 4, y I do, negative 6. Take that down and add the powers. I know what I've done. Swap the start again. So we've got y squared negative 3 all over x cubed. So this becomes x to the 4 over y multiplied by 1 over x cubed y to the 6. Okay, so we can cancel just to give x all over y to the 6. That is still unclear. It's a bit of a mess. Okay, x to the 4 all over y multiplied by y to the negative 6 all over x cubed. So we need to do x to the 4 all over y times 1 over x to the 3 y to the 6. So let's cancel. We're just going to get x over y to the 7. Okay. X, what have we done there? Okay, we've got this lovely question here. Okay, so remember the rule. If we have a over b to -1, that is the same as b over a. So we can apply that principle here. B over 3a to the 4 squared times, because we divide in, 3b over a squared. So let's work that out. We've got b squared all over 9a to the 8 multiplied by 3b over a squared. So we can perform some simplifications. The 3's go to get 3, and we simply left with b cubed all over a to the 10. Okay, so we are moving on. Okay, simplify fractional indices. So, for example, 8 cubed is 2, because 2 times 2 times 2 is 8. That is here 7. Something like 9 to the half is 3, because 3 times 3 is 9. So how about 8 to the negative? That is the same as 1 over 8 to the 3, which is simply 1 over 2. And 9 to the is just simply 1 over 3. So square root of 64 is 8. 6 times half is 3. This is going to be 1 over 8m to the 12 all to the third. So that is going to give 1 over 2m to the 4. So we distribute the half power. That gives 5. Square root of 81, or 81 to the half, is 9. W to the 8. Let's do this in red. Okay, so that is 100,000 all over x to the 20, and we can distribute the fifth. And the fifth root of 100,000 is 10 all over x to the 4. And we can show that fifth root of 100,000 is 10. By doing 10 times 10 times 10 times 10, we just count the zeros: 1, 2, 3, 4. 1, 2, 3, 4. Okay, not right. So the cube root of the fifth root okay, we've already done 1, 2, 3, 4. Yeah, this is correct. Okay, so that is everything. So we've covered quite a lot of material there. Just one final thing to note about cube roots is that the general formula, say we get m to the a over b, that is written as b root m to the a. And m to the a over b can be split up into m 1 over b all to the a. And that works out if you're working out, say for instance, 27 to the negative 2/3. So we can rewrite that as 27 to the 2/3, and that is simply 1 over 27 to the 3 all squared. Well, what three things multiplied together to give 27? Well, 3 squared is 1 over 9. Okay, so I think we will do one more and then finish. And the final question is, let's do that here. Let's do, I don't know, 81 over 144 all to the negative 3 over 2. So see if you can have a go doing that one using these principles. Let's pause the video. Okay, so hopefully you've done that now. So let's do that in my favorite color. So the question is 81 over 144 to the negative 3 over 2. Well, that is the same as 144 over 81 to the 3 over 2. We can distribute the half to get 144 to the half over 81 to the half, and then we can cube. So the square root of 144, or 144 to the half, is 12. Then 12 cubed is 1728. And the same logic, the square root of 81 is 9. 9 cubed is 729. And let's simplify that fraction. 1728 over 729. And that gives 64 over 27, and we can write that as a mixed numeral. That gives 2 over 10 over 27. Okay, so I think that's sufficient. Good luck revising for the exam. And that's all from me.